Welcome to Senior High School Math Series. In this presentation, let us discuss the chain rule under basic calculus. Let us begin our discussion with a problem. A particle moves along the line y is equal to 7x minus 3 in such a way that its x coordinate at time t is x is equal to 5t. Calculate dy over dt. As a function of t, we have y is equal to 7x minus 3 as y is equal to 7 times 5t minus 3. And that is because x is equal to 5t. Then we have y is equal to 35t minus 3. That is 7 times 5t. We have 35t. Therefore, dy over dt is equal to the derivative of 35t minus 3 with respect to t. Then we have dy over dt equal to 35. Take note that dy over dx is equal to 7. That is, when we get the derivative of y with respect to x, we get 7. Also, when we get the derivative of x with respect to t, that is dx over dt, that will be equal to 5. Also, notice that dy over dt, that is equal to 7 times 5, when we have dy over dx multiplied by dx over dt. This example works because the derivative of a composite function g compose f of two differentiable functions is the product of their derivatives. From this observation, let us state formally the chain rule. For chain rule, let us suppose that h is equal to g composition f is the composite of the differentiable functions y is equal to g of x and x is equal to f of t. Then h is a differentiable function of t whose derivative at each value of t is h prime of t is equal to g prime of f of t times f prime of t. The equation says that to calculate h prime of t, we multiply the values of f prime at t and g prime at f of t. The virtue of the formulation of the equation in the previous slide is that it tells how each derivative is to be evaluated. Let us have another formulation of the chain rule. One that gives less information but is sometimes easier to remember. The derivative of y with respect to t is equal to the derivative of y with respect to x times the derivative of x with respect to t. Or we have dy over dt at t is equal to dy over dx at f of t times dx over dt at t. The first equation is particularly memorable because it suggests thinking of the derivatives as fractions with the dx's cancelling on the right to produce the fraction on the left. As an aid to memory, this is fine. It makes no sense mathematically because derivatives are not fractions. Let us have an example. Find dy over dt at t is equal to negative 1 if y is equal to x cubed plus 7x minus 6 and x is equal to t squared minus t. Here is our suggested solution. From the equation, the derivative of y with respect to t at t is equal to negative 1. We have the derivative of y with respect to x at x is equal to f of negative 1 multiplied by the derivative of x with respect to t at t is equal to negative 1. First, let us find dy over dx. That is the derivative of y with respect to x. So we have derivative of x cubed, that is 3x squared. Derivative of 7x, that is 7. and the derivative of negative 6 is 0. So we have 3x squared plus 7 at x is equal to 2. Because f of negative 1, we have negative 1 squared, that is 1, minus negative 1. So when t is negative 1, x is equal to 2. Multiplied by the derivative of x with respect to t. So we have the derivative of t squared is 2t. The derivative of t is 1, so we have 2t minus 1. And that will be at t is equal to negative 1. Substituting x equals 2 and t equals negative 1, we have 2 squared is 4 times 3, that is 12, plus 7, we have 19. When t is negative 1, we have 2 times negative 1, that's negative 2, minus 1, we have negative 3. Therefore, the derivative of y with respect to t at t is equal to negative 1 is equal to negative 57. The familiar rule for differentiating powers of functions is a special case of the chain rule. If u is a differentiable function of x and y is equal to u raised to n, then the chain rule in the form dy over dx is equal to dy over du times du over dx. This gives the derivative of y with respect to x is equal to the derivative of u raised to n with respect to u times the derivative of u with respect to x. And the derivative of u raised to n with respect to u will be n times u raised to n minus 1 multiplied by the derivative of u with respect to x. Let us have an example. Given y is equal to, open and close parenthesis, x cubed plus 2x squared raised to the 5th power, find y prime, or the derivative of y with respect to x. Here is our suggested solution. Let u be equal to x cubed plus 2x squared. Hence, u is a differentiable function of x. The derivative of u with respect to x, therefore, is 3x squared, that is the derivative of x cubed, plus 4x, and that is the derivative of 2x squared. Then y is equal to u raised to the 5th power, since x cubed plus 2x squared is equal to u. From here, we get the derivative of y with respect to u. Then we have 5 times u raised to 5 minus 1, and that is 5 times u raised to 4. So we have y prime equals the derivative of y with respect to u times the derivative of u with respect to x. It follows that y prime is equal to 5u raised to the 4th power times 3x squared plus 4x. And since u is equal to x cubed plus 2x squared, therefore we have y prime is equal to 5 times x cubed plus 2x squared raised to the 4th power times 3x squared plus 4x. When using chain rule, it sometimes helps to think in the following way. If y is equal to g of f of x, then y prime is equal to g prime of f of x times f prime of x. That is, differentiating g, leaving everything inside, which is f of x alone, then multiply by the derivative of the inside function f of x. Let us have an example on this. What is the derivative of y is equal to, open and close parenthesis, 3x squared plus 4x minus 5 raised to the 5th power. So in this case, f of x is 3x squared plus 4x minus 5, and g of f of x is 3x squared plus 4x minus 5 raised to the 5th power. For our solution, y is equal to 3x squared plus 4x minus 5 raised to the 5th power. That is our given. Then, to get the derivative of this, we first get g prime of f of x, that is leaving the inside function alone. Then we have y prime is equal to 5 times the inside function, 3x squared plus 4x minus 5 as it is, raised to 5 minus 1. Then we're going to multiply this by the derivative of the inside function. Derivative of 3x squared is 3 times 2x raised to 2 minus 1. The derivative of 4x is 4. So we have y prime is equal to 5 times the quantity, 3x squared plus 4x minus 5 raised to the 4th power. 3 times 2 is 6 times 6x, because 2 minus 1 is 1, so we only have 6x plus 4. Let us have another example. Differentiate y is equal to cosine 4x cubed. We can look at this example as a composition of three functions. If h of x is equal to 4x, g of x is equal to cosine x, and p of x is equal to x cubed, then y is the composition of functions p of g of h of x. So to get the derivative of this function, y prime will be equal to p prime of g of h of x multiplied by g prime of h of x multiplied by h prime of x. So here is our solution. First, we have our equation y is equal to cosine 4x cubed. So we will get the derivative of cosine 4x cubed. That will be y prime is equal to 3 times the inside function 4x raised to 3 minus 1. And then we will get the derivative of the inner function, that is cosine 4x, and the derivative of cosine function and angle is negative sine function of the angle. So we have negative sine 4x. 4x is another inner function, so we get the derivative of 4x and multiply by this. So we have times 4, that is the derivative of 4x. Finally, we have y prime is equal to 4 times 3, that is 12, times negative sine 4x. So we have negative 12 times cosine 4x squared times sine 4x. Let us have another example. Given f of x is equal to sine 2x plus 1 raised to the 5th power, find f prime of pi over 2. Here is our suggested solution. First, let us get f prime of x. So we have f prime of x is equal to 5 times the inner function or the inside function, 5 times open close parenthesis sine 2x plus 1 raised to 5 minus 1. Then we're going to multiply this by the derivative of the inside function. The derivative of sine 2x is cosine 2x, and the derivative of 1 is 0. So we multiply this by cosine 2x. Still, we have another function, 2x, and the derivative of that is 2. So we multiply this by 2. Then we have f prime of x is equal to 2 times 5, that will be 10, cosine 2x times open and close parenthesis sine 2x plus 1 raised to the 4th power. After getting f prime of x, we will now get f prime of pi over 2. That is substituting x is equal to pi over 2 to the resulting function. Then we have 10 cosine 2 times pi over 2 times the quantity sine 2 times pi over 2 plus 1 raised to the 4th power. 2 divided by 2 is equal to 1 in cosine 2 times pi over 2. Also in sine 2 times pi over 2, we have 2 over 2 that is equal to 1. This time we can evaluate cosine pi, and that is equal to negative 1. So we have cosine pi equal to negative 1, and sine pi is equal to 0. And then we have 10 times negative 1 is negative 10. 0 plus 1 is 1, and 1 raised to the 4th power is 1. So we have negative 10 times 1. Finally, we have f prime of pi over 2 is equal to negative 10. That will be all. Thank you for watching. Please subscribe for more math lessons.